A 1.2 GB Java image caused 8-minute CI builds and pull timeouts on EKS. The Dockerfile had 7 run instructions, installed Maven with all dependencies, left the M2 repository in the image, and used a 400 MB JDK base instead of a slim JRE. No multi-stage build was used. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover optimizing Docker images. Optimizing Docker images means reducing size by understanding layers. Each instruction adds a permanent layer. The goal is to ship only what's needed at runtime. A naive Dockerfile installs everything in one stage. Build tools like GCC and curl end up in the final image, bloating layers permanently. Docker layers are like git commits. Deleting a file in a later layer hides it, but doesn't reclaim space. Always clean up in the same run instruction. Order layers by change frequency. Stable dependencies first, then code. This maximizes cache reuse and speeds up builds. Multi-stage builds use 2 from statements, one with full SDK to compile, another with minimal base to run. Only the compiled artifact is copied over. Here's a real multi-stage Dockerfile for a Java app. The build stage has Maven and JDK. The runtime stage only has JRE and the jar. Base image choice sets a lower bound on size. Full images are convenient but bloated. Slim, Alpine, and Distroless offer trade-offs between size and compatibility. 3 common base images: Distroless for security, Slim for general use, Alpine for static binaries. Pin versions to avoid surprises. Distroless and Alpine differ in libc. For most production apps, Distroless is safer due to glib compatibility. The size difference is minor. Compare the two. Distroless has no package manager, Alpine has apt. Choose based on your app's libc requirements. Layer caching speeds up builds. Put stable instructions first, code last. Use dockerignore to exclude files that would invalidate the copy layer. This Dockerfile orders layers from most stable to most volatile. System deps rarely change, Python deps change with requirements. Code changes every commit. A dockerignore file tells Docker what to exclude from the build context. This prevents secrets and unnecessary files from entering the image. Here's a production-ready dockerignore template. Customize it for your project, but always exclude Git, node modules, and secrets. Image size tends to creep. Monitor it in CI with tools like Docker Scout, set budgets, and fail builds that exceed them. This script checks compressed image size against a budget. Integrate it into your CI pipeline to catch bloat before deployment. Unnecessary packages increase attack surface. Distroless images have no shell or package manager, drastically reducing CVEs. Run Docker Scout CVS on every image before deployment. If your base image has hundreds of CVEs, switch to a slim or Distroless variant. BuildKit offers advanced caching. Cache mounts persist package downloads across builds, and cache pulls cache from a registry. Add hash syntax equals docker/Dockerfile 1.4 to enable BuildKit features. This cache mount reduces npm install from 45 seconds to 5 seconds on repeated builds. Hadolint checks Dockerfiles for common mistakes. Rules like DL3008 enforce version pinning, DL3009 enforces apt cleanup. This GitHub action runs Hadolint on every push. It fails the build on error-level violations, catching bloat early. Treat image size as a metric. Set budgets in a YAML file, check compressed size in CI using regtol, and fail builds that exceed limits. This script reads a budget from a YAML file and compares the compressed image size. It fails if the image is over budget. This is the same issue we highlighted at the start. Here's exactly why that 1.2 GB image happened. The Dockerfile installed build tools like GCC and Maven, then tried to clean them in a later layer, but the bytes remained in the layer stack. The fix was multi-stage. Build with Maven in one stage, then copy only the jar to a JRE Slim runtime. The image dropped from 1.2 GB to 145 MB, and deploys went from 8 minutes to 45 seconds. Copying the whole build directory drags in source code and intermediate files. Always copy only the specific artifact, like *jar. This is the exact mistake from the incident. The rm command in a separate layer doesn't remove the files from the previous layer, they're still there, hidden but costing size. If you clean apt cache in a separate run, the files still exist in the previous layer. Combine install and clean in one run to actually remove them. Alpine uses musl libc, not glibc. If your binary expects glibc, it will fail. Always test thoroughly before switching to Alpine. Without dockerignore, every copy includes Git and Node modules, invalidating the cache and slowing builds. Cache mounts persist on the host file system. On ephemeral runners like GitHub Actions hosted, they don't persist. Use cache from with a registry instead. The article mentions mount equals type equals cache, but doesn't show a concrete example for pip. Here's how to cache Python packages across builds without bloating the final image. The article notes that common base layers are shared on a node, but misses a key nuance. Using copylink, BuildKit creates layers that are independent of the previous layer, improving cache sharing across different images built from the same base. This is especially useful in monorepos with multiple Docker files. The article warns that cache mounts don't persist on ephemeral CI runners, but doesn't mention that cache from with a registry is the only reliable pattern there. Additionally, cache mounts can cause subtle bugs if the cache becomes stale. Always include a cache-busting mechanism like a version file. To diagnose bloat, start with Docker image history to see layer sizes, then use Dive to interactively explore each layer's files. Docker Scout gives a quick size and CVE summary. Let's run through some common interview questions. How do Docker layers affect image size? Each instruction adds a permanent layer. Deleting in later layers doesn't reclaim space. What is a multi-stage build? Using multiple from statements to separate build and runtime environments, copying only the artifact. Why prefer Distroless over Alpine? Distroless uses glibc, avoiding compatibility issues. Alpine uses musl and may cause runtime errors. And a few frequently asked questions. What is the most effective way to reduce image size? Multi-stage builds, cutting size by 85–95%. Should I always use Alpine? Only if your app is fully static or musl compatible. Otherwise, use Slim or Distroless. How do I prevent size creep? Set size budgets in CI and monitor with tools like Docker Scout. To recap, understand layers, use multi-stage, pick the right base, order instructions wisely, and enforce size budgets. These practices will keep your images lean and your deploys fast. Ready to go deeper? Up next, Docker Networking Deep Dive, then Docker Containerization Explained, 2026 Guide, then Docker in Production. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.